Most of us have a pretty specific memory of what math class felt like. But the way it's taught today, it has completely changed. We're going to crack open a modern textbook to really understand the philosophy that's shaping a whole new generation of problem solvers.
Yeah, remember that feeling? You can almost smell the chalk dust. Just an endless board of formulas and rules that you had to memorize. For so many of us, math just felt like this abstract world of numbers with zero connection to real life.
But what if the whole point of math class was never just about getting the right answer? Well, today's textbooks are built on a totally different idea. They're shifting away from that abstract, just the numbers approach to one that's all about real-world context.
So here's the big difference, right? The old way was like being handed a key and told which lock to open. Simple. The new way? It's more like being handed a locked box and a bunch of random parts, and your job is to figure out how to build the key yourself. The focus is way less on just calculating and way more on thinking.
And this change, it didn't just happen by accident. No, it's a very deliberate philosophy. And the best part is, the textbook tells us exactly what it is, right there in the foreword.
This right here, this is the bedrock principle. It's all about breaking down the wall between the classroom and the real world. The idea is that math shouldn't be something that only exists in a book. It should be a tool that you can actually use to understand everything around you.
And this really gets to the core of it. The student isn't just an empty bucket waiting for facts to be poured in. You're an active participant. You're a detective. You're a problem solver. The real goal is to develop a way of thinking, not just a list of things to memorize.
Okay, so before we jump into the problems, let's get one key term straight. Algorithm. It sounds complicated, but all it means is a set of steps for solving something, like a recipe. The old way of teaching was about memorizing the recipe. The new way is about learning how to cook, so you can create your own recipe when you're faced with a messy, real-world situation.
And check this out, a little bit of history. The word algorithm isn't some cold, scientific term. It actually comes from the name of a person, a 9th century Persian mathematician, Al-Khwarizmi. It's an awesome reminder that math has always been a human story.
So, what does this philosophy actually look like in practice? Well, we're about to see how these books use things you can actually relate to, like folk puzzles and simple games, to teach some surprisingly complex ideas.
Okay, take this problem. This isn't an equation, it's a story. It's a little folk puzzle about an egg trader. It's designed to make you curious, This riddle turns what's basically a math problem about remainders and multiples into a genuine mystery.
And here's the thing, the answer, which is 119 eggs by the way, isn't even the most important part. The real lesson is the process. It's teaching you how to translate a story into math and then use concepts like the least common multiple to crack the code. That's the actual skill you're learning.
Or look at this one, a trip to a village fair. This is secretly teaching linear equations, but it's disguised as a fun problem about rides and games. It connects something kind of abstract like algebra to something we all get, having a budget.
But it's not just about puzzles and games. These next examples show how mathematics is the literal language we use to design and build the world around us.
Now this is a classic real-world problem. You've got constraints, a specific area, a rule about the length and width, and you have to figure out the dimensions. Just like that, a practical construction project turns into a quadratic equation that you have to solve.
Oh, I love this example because it's so visual and practical. Instead of some sterile triangle on a page, the problem is about an electrician, a pole, and a ladder. It makes trigonometry instantly relevant. You're not just finding the hypotenuse, you're figuring out how long a ladder you need to do a job safely. And then you get problems like this, pulling in concepts from physics. It just goes to show that math isn't some isolated subject. It's the foundational tool for all the other sciences, used to model everything from the speed of a boat to the orbits of planets.
So, we've seen puzzles, games, construction problems, physics questions, but what's the ultimate goal here? What's the real answer this whole teaching method is looking for?
This is the big question, isn't it? If it's not just about getting the right number at the end, then what is the point of framing every single problem as a story or a real-world challenge?
And here it is. This is the real answer. The goal isn't just to make you good at math. It's to build these skills that you'll use for the rest of your life. This approach isn't about training future mathematicians. It's about teaching a way of thinking that's valuable whether you become an artist, an entrepreneur, or that electrician with the ladder. It's about learning to reason, to solve problems creatively, and to see the hidden patterns in the world.
So let's end on the one powerful idea that's really at the core of this entire philosophy.
This quote from the preface just says it all.
The ultimate goal is to completely shift our perception, to stop seeing math as this foreign, difficult language, and to start seeing it as a natural, essential part of our world, often hiding in plain sight.
And that leaves us with a question for you. From the algorithm that suggests your next song, to the layout of your grocery store, to the timing of the traffic lights on your commute, now that you know what to look for, where will you find the math in your world?